Quality Special Symposium presented by the University's Council on Water Resources and the University of Minnesota Water Resources Center. My name is Marcel Lewandowski. I'm with the University of Minnesota Water Resources Center, and I am joined by Dr. Anna Cates, our Minnesota State Soil Health Specialist, and Hava Blair, also at the University of Minnesota with the Department of Soil, Water, and Climate, and Jackie Krim, who is with UCOWR, and will be hosting this event today. So one more note, this event is being recorded. So Jackie, if you'd want to start recording, that would be great. So a bit of background on this. Our original intention was to present this symposium at UCOWR's June meeting that was canceled. But the participants were still very interested in having these discussions around this topic of soil health and water quality and the nexus of the two. And also there's a group of folks that are interested in publishing in a special issue with the Journal of Environmental Quality. And so we were making plans to do that. And if anybody is interested in joining and contributing to that, please contact myself or Anne-Marie Fortuna. We would love to get some more contributions as part of that. As this symposium itself, we had 4 goals that we were trying to achieve. The first is to frame this issue, the issues. How are we talking about soil health and water quality together? The second is to identify research needs and gaps. The third is to identify how this soil health information can inform watershed management and how we can improve watershed management using these ideas. And then the last is to inspire some new projects and collaborations, and hopefully we'll get some cross-seeding of ideas. The main way to participate today, we'd really like to have your insights and questions and so on. And at the bottom of your screen, you should have a Q&A link. And if you click on that, you can add, contribute questions, and you should be able to comment on questions as well. And our panelists will write answers there as we're talking if we don't manage to get to them as we're speaking. The agenda today, or how this symposium is going to play out, is we're first going to spend the next half hour with real quick presentations from each of the people whose presentations you may have already watched, the recorded presentations. And we'll have about 2 minutes from each so they can introduce themselves and remind you of what their key points were for each of them. And then after that, we're going to have some discussion on some of these larger issues, this framing of the topic, identifying research needs, identifying the linkages to watershed management, those bigger overall questions. To the extent that you have more specific questions specific to the presenter, certainly contribute those questions and add them to the Q&A. We may or may not get into those in detail as we're talking, but we will do our best to answer those in writing as we go or afterwards. Anything else from our other hosts here before we jump into some introductions? Okay. Oh yeah, I guess I did have something else. I guess we'll start with the overall presentation. This was the framework that I had presented in my presentation, and Kevin Ferminek and some of the other presenters also were getting at some of these same ideas. And so I encourage comments from people about how well this works for you, and how well does this work for you? Yeah, we'll get into this more as we get into the questions. Okay, Let's start with some introductions. And first, I'll turn things over to Will Osterholz.
Okay, I guess I'll start things off. Yeah, my name is Will Osterholz. I am a soil scientist with USDA ARS, the Soil Drainage Research Unit in Columbus. Our research group here is mostly focused on understanding processes that control edge of field water quality, specifically in agricultural landscapes, mostly in the Eastern Corn Belt, so Ohio, Indiana area. And a big component of this work is investigating the soil properties and the processes that contribute to the water quality signatures that we see. So that's really what my research program is focused on. In the talk I shared as part of this symposium, I mostly discussed how we view the importance of water quality in Ohio. And also I touched on some of these same reasons of why we expect soil health properties to in part control water quality. So that was a bit of overlap with several of the other presentations. And then, yeah, I laid out the study that will be contributing to the special issue of the Journal of Environmental Quality. So for that research project, we'll be using edge of fields water quality, so basically nitrogen and phosphorus losses from the large edge of field monitoring network that we've been maintaining over the past decade. It's 38 fields. So it's a pretty large data set, which I think is one of the real strengths of the analysis. And so the idea is to pair the water quality data with some soil health measurements that were taken in the fall of 2017. And eventually we'll be developing regression relationships between those two pieces of data. Unfortunately, I'm right in the middle of that analysis, so I didn't have any results to show, but hopefully at least the approach sounds interesting and people are as excited to see the results as I am. So.
Thank you, Will. Next on our list here is Kevin Ferminek from the University of Wisconsin-Green Bay.
All right, good afternoon, everyone. Again, I'm Kevin Ferminek, University of Wisconsin-Green Bay, and my presentation on challenges in linking soil health to edge of field water quality across Great Lakes Basin is really part of a larger study where we're looking at making these linkages across the Great Lakes. And the work is being done in cooperation with USGS, edge of field monitoring sites, as well as with Purdue University and Nrcs. Our real challenge here is that we know that field management is linked to water quality, and we know that soil health and field management are linked, but this question, as Ann mentioned, of how do we link the soil health to the edge of field water quality? And kind of our big takeaways in our study is that so far, we're on working farms, and that creates a lot of challenges, particularly on factors beyond soil health that affect edge of field water quality. And our challenge is to determine that signal of soil health relative to the other big drivers. And the other big drivers being some of the landscape factors, the farming practices, the management history, obviously the hydroclimate differences among sites, soils, drainage, those types of things. And then one of the other big takeaways for ours was the farm system. Turns out about half of our sites are in dairy agriculture and half are in row crops. And that's a critical point for us to take into account. We originally were sort of taking the approach, if we measure soil health independent of many of these other things, that we could link that to water quality. And we're not seeing that, I guess, easy linkage to be made. And one of the key linkages, as far as phosphorus, which is the key variable that many are interested in edge of field water quality, is that it's something that I guess we've known about a long time, right? The amount of nutrients in the water, the chemical soil health property, particularly total phosphorus, is a big driver of what we're seeing beyond all our other soil health characteristics. As far as where we're headed, like Will, we're still sort of early on in our analysis, but we're going to continue with looking at more multi-year and spatial components to our data and multivariate analysis. And then ultimately, I'd like to have a soil health index that's predictive of edge of field water quality. I look forward to our further discussions. Thanks.
Thank you, Kevin. And next on our list is Arun Bawa.
Hello everyone, my name is Arun Bawa. I am PhD candidate at South Dakota State University. My contribution to this symposium is a field study where we try to quantify the changes in the nutrient concentration living through the subsurface drainage system after planting the rye cover crop. So the study is conducted in the Southeast Research Farm, where the soil is dominated by the poorly drained but highly productive soil. So the motivation for the study was that the cover crops are widely demonstrated as the environmental friendly and agricultural friendly practices, conservation practices. But their impacts, their positive impacts over here in the South Dakota, especially where we are facing a short growing season and cyclic climate conditions, some wet springs, and then again after some time dry springs, how these conservation practices are going to impact, how they are going to introduce the positive impacts here in these areas. So overall in this study, I have tried to show that how the management decision for the cover crop practices have impacted the desired environmental benefits from the cover crop. Let's see. I hope for a good discussion here.
Thank you, Arun. And next is Gray Evenson from Ohio State University.
Hi, folks. My name is Gray. I work with Margaret Kalsick at Ohio State. She unfortunately couldn't be here today because she just fortunately gave birth to a healthy daughter. So she's busy at the moment. So I'm filling in. Margaret and I are watershed modelers, and we're actually, before I get into that, I just want to briefly mention Collaborators. So we are going to produce a publication, and Will Osterholtz and Kevin King and Vinayak Shedekar at Ohio State and USDRS are collaborating with us. But as I said, Margaret and I are watershed modelers, and we're working with this on this problem that some folks have suggested that our watershed scale models might be a little bit flawed in their representation and simulation of soil health practices. So we're working to develop methods to improve that representation of models. And so our presentation kind of went through our efforts to do that and looked at some initial results. So the primary takeaways at this point are that we do have this kind of new improved method of representing soil health practices in our models, but our initial results are showing that our changes to soil physical properties aren't making substantially different, aren't producing substantially different simulation results. And of course, there are a couple of reasons why that might be. Well, there are a variety of reasons, really. I think it'd be important for me to mention one particular reason is that we don't have data at this point, and so we're hoping to work with Will Osterholtz and his group to produce take some field observations and validate our model results. So so I'll leave it at that. So thank you.
Thank you. And next is Lee Fomenson.
Yes. Let's see here. Hang on a sec. Yes. Okay. Share. Okay. Hang on one sec. Okay. Okay. Yeah, my name is Lee Fomenson. I'm a researcher at the University of Minnesota. I have over 20 years experience developing remote sensing applications that create temporally and spatially rigorous data sets of water and land resources for large ecosystem characterization. I'm particularly interested in developing field validated image processing methods implemented in automated geospatial analysis systems, such as Google Earth Engine and on our Minnesota Supercomputing Institute, supercomputers, to get a better understanding of natural resource environment. Currently, I lead a team of researchers and computer scientists to build a near real-time water quality monitoring system for Minnesota for over 10,000 lakes, using satellite imagery to provide critical water quality information. My presentation was kind of long, so I broke it into two parts. So the first part is a background about our what we do for water quality assessment, and then how we implement that on an automated high performance computing environment. And then the second talk is looking at spatial and temporal trends using watershed stressors and the daily soil erosion measurements from folks at Iowa State. And the big takeaway from my talk is the slide I have up here is basically that, let's see if I can just do that, water quality is actually decreasing in lots of parts of the state. A lot of the agricultural areas have some of the biggest decreases. Higher percentage of lakes are decreasing rather than going back, improving. So that is definitely a concern. Another thing is there's a lot of them in our more pristine areas up in the northern lakes and forest ecoregion, where basically there's not a lot going on except for forest harvesting, and those tend to be affected by something else. So basically, I've kind of found so we have this water quality is declining. Our analysis indicates it's both associated with both the climatic factors, the precipitation and temperature, as well as land use intensification. So it's a bunch of different factors all acting at the same time. So really, we're kind of working on trying to fill it. We have a historical database of 5-year intervals. So we're hoping to be able to fill that in so we can get a lot more time steps, so we can see some of the swings with the dry and the wet and warm and cool different periods, and see what kind of analysis we can see, because these are very complex analysis. And that's, I look forward to discussion today.
Great, thank you, Leif. Next is Jess Gutnick.
Hi, I'm Jessica Gutconnect, and I am a soil ecologist at the University of Minnesota Department of Soil, Water, and Climate. And my other expertise is in climate change and climate adaptation, especially in some mitigation. So the talk that I presented was kind of was presented by Anna, Keats, and I, and it is kind of a first comprehensive shot at analyzing a big data set that we hope to publish as part of the special issue. And the talk that I gave was in 2 parts, and although you can't see them, I'm staring at my slides. The first part of this project was a large soil health assessment across 25 farms in the state. This was in partnership with the Nrcs, and we looked at several different indicators at all of these farms. And another interesting part of that was that it was based on an equip incentive program. And so we kind of also get to ask the question of how well do some of the incentive programs work? And so that kind of overall survey was one part. And the second part of this was that I went back to some of the farms and simulated a 50-year storm, which is actually, not that big of a storm compared to how rapidly our climate is changing in Minnesota. And that, I think, is a piece that adds to this water quality question. Can I bring in the context of the fact that our climate is rapidly changing? And so, does soil health convey water, these water quality benefits, but also does soil health, or does improving the soil kind of give us an insurance policy against climate changes that are happening? And so that was the other kind of piece of this study that we did. And what we have found so far is just a lot of variability. And so we see that on some farms, we see lots and lots of gains, even, with the, this kind of moderate levels of building soil health. And in other farms, we don't see any impacts at all. And so kind of our next steps, and today we get to reflect on this a little bit more with you all, and our next steps after this are to kind of go back to this data set again and kind of ask more about the farms that are doing well versus not, based on some information or whatever information we have, and kind of untangle some of this variability.
Great, thank you, Jess. Next up is Mike Kucher from USDA NRCS.
Yeah, thank you. I'm just going to briefly cover what my presentation was. First of all, I am an agronomist at the National Soil Survey Center here in Lincoln, Nebraska. And I covered use of ecological sites, which are basically grouping soil map unit components across common climate areas and common physiographic regimes. And then using that to support the planning process, 9 conservation planning. And then those ecological sites would be similar in the fact that they would have similar suitability and limitations for land uses and practices. Also, using those state and transition models are the different conditions, if you will, if you went out into the watershed and found growers that have been practicing soil health management for a long time, as you can see in the model in the right, versus some of those that have just started into a soil health management system, maybe some limited no-till or whatever it might be, versus more conventional management. And what kind of response or similar response would you expect, as you move from one management system to the other? We have a number of dynamic soil property studies that we're looking at, and also tying it back to what the reference condition or the optimum condition you could achieve for various soil health indicators within that ecological site. And then also we can make connections to some of our models, such as our process-based models like WEP, which is a water erosion prediction project, and WEPS, which is our wind erosion prediction system that looks at the impacts, risk management over up to a 100-year period, and then tying those models to the conditions you would expect to find within that land use. So again, it's just decision support. We've historically within NRCS been using ecological sites for rangeland and forest land across the country. We've made an effort to at least get our sites identified as to across the entire country. We're working on that extensively at this time. So again, that's what I had. Thanks for your attention.
Thank you so much. And next up is Anne-Marie Fortuna. Is Anne-Marie on?
Sorry, oops.
There we go.
Sorry, I didn't realize it didn't unmute right away. So I don't have a lot of data currently. So much of my talk at this point is going to be big picture, but a lot of it was inspired by discussions of this group, and then also NP211, which is our water management group. And so we have some long-term data sets that could be modeled, and we have some gaps that we could fill using some new technologies. And then hopefully by the time we have our manuscripts in preparation, I will show how the archive data with the current developments and technology can aid us in adopting policies for regional and state water planning and aid growers in making informed, fact-based decisions in real time. So
Great.
that way.
Thank you. And next up is Francisco Arriaga, University of Wisconsin.
Hi, everyone. So my name is Francisco Arriaga. I'll be transitioning here because I had some animations here, and I don't know if it kind of shows off. Give me a second, click here. You should be able to see a slide right now, right? Title slide. Perfect. Yep. So I'm an associate professor and a state specialist in the Department of Soil Science and the Division of Extension at the University of Wisconsin-Madison. My program focuses on management practices for soil improvement of agro ecosystems. I have a special interest in soil health and water quality. My training is in soil physics, applied soil physics, I like to call. And so my presentation kind of combines some research that we've been doing here in the state. And one of the specific things and issues that we have in Wisconsin, I guess before I get into that, I acknowledge my co-authors, Perez, who's working on his PhD in biosystem engineering, and Dr. Anita Thompson, who is his advisor, and I co-advise Laxmi with Dr. Thompson. So some of the data you'll see here comes from some of the work he's done and prior students of mine. So in Wisconsin, we have the problem of silage systems, right? We're the dairy state. We have a lot of dairies, so silage is a popular crop, and this might be a very specific problem, but I think it translates to other scenarios. And so after silage, you can see there's very little residue left, so there's a greater risk for erosion and phosphorus losses. So some of the things we're looking at, it's cover crops and reduced tillage. Can these help offset? And so I share with you in the presentation two different pieces of information or two different projects. The first one was honing in on cover crops, but also we looked at tillage. And in this case, we were looking everything received manure, which was injected. And so we used a rainfall simulator as a tool to look at this. And what we found was the cover crop was very effective in reducing runoff overall for the entire year, but it depending what time of the year. In the fall, after establishment, there's very little residue from the cover crop, so we had a lot more runoff, a lot more losses. But then, fast forward to April or so, there's more biomass, so we have some benefit from there. And then going to June, where you already have a crop growing in there, a no-till system, that's the only time we saw tillage actually made a difference, was actually in early spring. A no-till system left some of the residue on the surface, and that actually helped reduce some of the losses. So it sort of mattered. Overall, cover crop had the overwhelming factor, and tillage was more of a secondary factor here. We also have done some soil health assessment, and we found improved aggregation and other parameters within the cover crop. But, in this part of the world too, we also get frozen conditions during the non-growing season a lot of the time, or most of the time, right? And so we have another project that's been going on since, I believe, 2014, where we're concentrating more on the tillage. And so the idea here was to look at a smooth surface, relatively smooth surface represented by no-till, and then a rough surface by the full chisel. And we were looking at originally at manure applications during the winter and seeing which system might be more beneficial to try to minimize those losses. And so what we found overall is that we get less runoff and less phosphorus losses under a chisel and the no-till. And it doesn't matter if there's manure applied or not, we still see that effect. And part of the reason the infiltration capacity of those two conditions of these two soils are very similar. But when the soil freezes, we know that the infiltration capacity overall, it's greatly reduced. And so what we hypothesize, our hypothesis is what's happening is that on the full chisel, we have a lot of depressions left in the field. And so that allows for that snow melt to be in greater or longer contact time, have a greater contact time with the soil. So we have less runoff under that scenario when we have frozen soil and then a little bit later on. If we look at the year as a whole, we actually still see less runoff under the chisel, but we do see a little bit more sediment loss when the soil thaws out on the chisel compared to the no-till. And so that's sort of the gist of this is that conservation practices are important, but I think we need to think about, where in the landscape they are they might not be beneficial for water quality per se. Something that works in a field might not work in another scenario. So that's something that we need to be recognized and be cognizant of. So I feel like there's still a lot of work that we need to do to kind of figure these things out. I think one of the questions that Anne wanted to address is where the research program is going. So I think I would like to continue looking more of these winter processes and kind of try to hone in what soil physical properties might be important. And I think aggregation, it's one of them that we really need to concentrate on to try to link water quality and soil health parameters.
Great, thank you, Francisco. Next up is Michelle Perez from the American Farmland Trust.
Thanks, Anne. Can everybody hear me?
You bet. Sounds good.
Great. I wanted to say a few words of thanks to Anne and others for inviting me. I'm a little bit of a fish out of water, the only non-scientist of the bunch. And hopefully you'll all get to enjoy very soon this report that I featured. It's a guide to water quality, climate, social, and economic outcomes estimation tools with my colleague, Dr. Emily Cole. And I'm the Water Initiative Director for American Farmland Trust, a small to medium conservation group that is trying to provide resources to over what we estimate to be 1,000 RCPP regional conservation what does RCP stand for? Regional Conservation Partnerships Project Program project leaders and MRBI project leaders and EPA 319 project leaders, right? So there's an alphabet soup of federally funded conservation projects, maybe to the tune of 1,000 of them across the landscape, that are collaborating with tens of thousands of farmers on millions of acres. And the Farm Bill has asked them to quantify their outcomes. Over 65%, I believe, of Nrcs conservation funds goes to water quality related practices. And so we were an RCPP project ourselves 2 years ago, and we were struggling to figure out, well, how the heck are we going to estimate our outcomes? So that is the originating reason for this paper. And what we've come up with, I'm going to just jump to the water quality section, are seven water quality tools, can't remember my own paper, that we think meet our criteria, which is the majority of the RCPP project leaders, we believe, are not technical modeling experts like many of you on the program here, and they need tools that they have the staff capacity to access, unless they build in a big enough budget to hire the private sector and the academic sector to join them. So we scoured about 50 different tools and models and found the ones that we think are actionable right away, that are tools and methods for use by our fellow conservationists and ourselves. And these are the tools right here that work at a variety of scales and focus on a variety of water quality concerns. I wanted to show you that we also tried to pay attention to scale, as many of you have mentioned, and trying to get to the next page right here, sorry. We wanted to emphasize that, different tools work at different scales depending on the purpose their tool developer created them for. So there are field focused tools on this side of the screen, project, sometimes watershed, county delineated tools on this side of the screen. Blue stands for water quality. So your eye can be guided to see that we only found a few tools that actually can do both, provide field scale estimates of water quality outcomes, as well as be able to aggregate those outcomes up to the project level, which may be a watershed. So I thought that was pretty interesting. And finally, I wanted to jump to the recommendations, as I really appreciate hearing, big picture long-term goals from several of you. I mention you, the land-grant university academic community, in our final, out of 14 recommendations, our final one is the big one, and we are calling for the establishment of a nationwide data set to generate the calibration data that you all as modelers need, and many of you are on the phone who are in the actual scientists in the field developing that data that can feed into the models and tools and make them better, stronger, and more credible. So I'd love to have a conversation today to now and into the future on how we make that happen so that the modelers get the data they need and you generate the data that will work for them, and then the tool users, folks like us, get the training we need to be able to quantify these water quality outcomes. Thank you.
Great, thank you, Michelle. And finally, Ross Wilson from Ontario.
Good afternoon, everybody. Ross Wilson from the Assolvable Bayfield Conservation Authority. It's a 600-acre watershed on the southeast shore of Lake Huron, a mixed agriculture. And what we've been able to start out with was a little bit of research towards soil health. It grew out of our watershed report card. Our watershed report card gave a report card grades A to D on various elements of the watershed, but it started out as water quality, then it moved into forest cover, then it included wetland. And about 2015, after the UN Year of the Soils, we realized that we really needed a soil component, a soil health component to tell us how healthy our watersheds were. And so this work grew out of that. We looked at 19 different farms. We looked at soil health. We compared the soil health to natural areas adjacent to those farms. And we broke them down into 4 different soil types. And what we ended up finding essentially was that depending on which soil metric you were looking at, the level of degradation or the grade was somewhere between a C and an abysmal failure. So somewhere between fair and just abysmally poor. So if you look at one metric, it might have said fair. You look at another metric, it tells you something else. So then the question became, okay, well, we only sampled 19 farms. How do we make sense out of that on our 600 acres of watershed? Which of these metrics do we use and how do we scale up from it? So it's been a learning process. I think for me, the big take-home message was really that we just needed to get started at this. Every time you tried to scale up, we looked at it, do we do it this way, do it that way, and we saw limitations to a lot of our approaches. But then we just got into it, and it seems to be an iterative process, and we're learning more all the time. And even just our introduction here has been a great process. I know we're on the same page here, and looking forward to the rest of the afternoon.
Great, thank you, Ross, and thank you all of you. And if you haven't had a chance, those presentations will be there for a bit, so you keep watching, check out the ones that you're interested in. At this point, I want to shift into discussion amongst the panelists. Please submit your questions in the Q&A box at the link at the bottom of your screen. And the first question I want to throw out to the panel is, well, in the framework that I presented, I really pushed the idea that we need to focus on the soil properties instead of just looking at management. But let's flip that around and say, maybe that's not true. So the first question is, are you happy using management as a proxy for soil properties? Maybe that works okay. Or should researchers continue to look for sensitive soil properties? So I'll just open it up.
So I'd like to say something, and I can link it to a couple of the talks. I think scale is critical, and this relates back to the scale. So what a farmer needs for detail is probably going to be more at the field level. But if we're looking, and actually, I think at the field scale, some of the things related to stacking conservation management needs that level of detail to figure out what's going on. So there's been a number of people that have talked about, the difference between the chisel and the no-till, and then cover cropping, and that came up in soil and water conservation this year for your region as well. And so I think that aspect, the soil properties become critical. But when you're scaling up and you're looking more at a state-based map, I think you have to find a way of aggregating those details into zones or, you know, regional units. And so maybe the output of one model can be used in an aggregated form in the input of another. And I don't think we really have a means currently of linking different models at different scales, but I think we need the data sets as the foundation. And I like, you know, the call for having a nationwide data set that's supported by, you know, Farmland Trust, and then is an objective of SEEP and LTAR. And so I think both things are correct. It just depends on the question you're answering and what scale those questions are at, and that's going to vary. And that's why it is really a multitask pronged research approach that's required, that enables us to share back and forth.
Thank you, Ray.
And this is Mike. I'll just chime in real quick. What you kind of posed as a question, the ecological site concept and using state transition models is exactly what you're describing. We're looking at more or less using the management options as a way to segregate different states, but you still have to have soil quality or soil health indicators to see where you are in that journey, because they're as soon as you adjust management, you don't get a change in soil properties and get those desired impacts immediately. It takes some time, in some case, depending on the intensity of the management. So one of the things that we're hopeful to do is connect some of the research you folks are doing with our soil survey database. So what is the potential of different ecological sites to improve some of those key soil properties? And so if you do go out on site and you know what the previous management was, how long it was in place, and then what your new management is and how long that was in place, and then what are some of the key indicators at that point in time. So again, I think you need both to complement them.
Yeah, I'd like to add to both Anne-Marie and Mike's comments. I agree with both of them. And I think another important piece here is that when we're looking at parameters, you know, putting them in context, you know, wherever in the landscape they are, but also for a particular soil and situation, what is the value that we should be aiming, right? A lot of the times we kind of don't have kind of a target or a threshold that we should be shooting for. And I think that's where the work on looking at the parameters individually, it's very critical to try to figure out where those thresholds might be.
Yes, and I think what you did, Francisco. Oh, did somebody else say something? Go ahead.
Yeah, I was just about to kind of play off a lot of what Mike was saying about being able to merge a lot of this with soil mapping efforts. And if we're thinking about also kind of how to, if we have an aim for more adoption of these practices, you know, I think we're all kind of struggling with a lot of details and a lot of information and variability that needs to be teased out. But I think generally the reason we're all here is that we see some value in getting these practices more widely adopted. And I wonder about this scaling, because we have to also, like, if we're using, you know, an indicator or management, like, I think we also have to kind of walk hand in hand with farmer goals and the value and the goals of a given piece of land. And I don't always see how that's scalable. I mean, maybe there are some generalizations and some benchmarks that we can kind of carry with us, but it seems like a lot of this work still has to be at kind of an individual farm or an individual place level also. And so I kind of go back and forth of seeing where the work needs to happen, generalizing, or where the work needs to happen. How do we work more closely with individual farms and in individual places to understand how these things play out?
So I think your research where you're aggregating farms, you know, what I was thinking is If you have some information that's at the detail level, like Francisco in his example had, where if you pair certain things together, it doesn't necessarily benefit and fit the paradigm of no-till. And in your situation where you were on the farmer's fields, you were saying in certain instances you would think that you would get a certain outcome, but you didn't. And so I think taking those more specific examples and then setting up a decision tree after getting enough individual smaller farm information together, where if you have a texture with a management with a certain climate, which you nicely outlaid in your talk about climate variability and adaptation, then you go to the next part of the decision tree, and hopefully over time we figure out which factors on a smaller scale lead to certain outcomes. And then I hope that we can scale it up so that if someone's using like a better version of Comet that has climate in it or something, that you could put in some parameters, predictive parameters, and forecast what would be good or bad under a certain set of climatic factors, because you're always going to have trade-offs. And organic, you put a lot of inputs and you have this bank of nutrients. And what I was looking at that was kind of on par with some of the talks is that as you build nutrients, you can lose them. So if you have phosphorus, that's good, but after a critical threshold, that could be bad because then you've got it in the water. And so that's a nice example that I think was repeated several times throughout the talks. And that's why it's great that we're looking collectively at everything together, I think.
Yeah, I wonder if that kind of more directly answers the question that you asked us, Anne. Yeah, maybe we can't use management as a proxy. Maybe we have to look at how maybe we still do have to look at how those soil characteristics are changing, because management could have different influences in different places.
I don't know if the data always bears that out, though. There's a lot of cases where we're seeing a difference with management without seeing a change in soil properties, a difference in water quality without seeing a change in the soil properties we're measuring. And that's what really gets under my skin as a soil scientist. Like, we're not measuring the right things here because the water is physically going through the soil, and the water quality is changing because of management, but we're not measuring the thing that's changing the water quality in some cases. And so while it may not be, we may be able to make good models and predictions and policy without measuring the right thing, because this management is a pretty good proxy. As soil scientists, I think we need to do better. And I see Francisco nodding, so I know I'm not the only soil scientist who feels this way.
Yeah, I think so too. So are you? Yeah, I agree.
I would be interested to hear from Gray Evenson on some of your work, because I didn't quite understand what, as you were adjusting the soil parameters in SWAT, you came to the conclusion that changing the tillage and cover management alone would have gotten the effects that you wanted, and not changing the soil parameters. Am I understanding that right? Or what are your learnings?
Yeah, I mean, that was, so overall, also using SWAT, there are some built-in representations of cover crops and no-till practices. So, and a lot of folks use just that when evaluating soil practice impacts on water quality losses. Now, we went into it thinking that, or what the hypothesis is, that using those representations wouldn't be the whole story. So we tried to manipulate different parameters in the model, such as water holding capacity and organic matter, or some other parameters that we talked about in our talk. But it ended up being, when we looked at the results, that the model was predicted a much more change from the actual practice of cover crops and no-till. So the plant being in the soil and uptaking the nutrient. That was the driving force that's behind water quality improvement. So, but so yeah, I mean, I think our initial results at least are showing that those management practices are the driving factor. But it's not to say that we plan to outline some limitations in our paper that, are changes to these parameters. So how much we increased water holding capacity, for example, those changes are uncertain. And then also it could be that the model just, the structure of it is so that it's not sensitive to the water holding capacity. It could be a variety of different things, but at least our initial results are showing, yeah, the management actions are what's driving things.
So this gets back to Anna's comment about what, are we measuring the right thing? In the soil, are we modeling the right thing? And so what is the most important thing that we should be measuring? What does seem to work?
Well, I mean, again, our initial results, I think, imply that, we've tried to pull out some important parameters from the model and say that these are the most important things, because they kind of translate good into the soil health literature, like water holding capacity, for example. But in my mind, and I think people are starting to measure these things. It's just that we don't have enough data to make those changes according to data. So what we did is we assumed a 1% increase for organic matter, and we just used some pedotransfer equations or predictive equations to predict how much water holding capacity or these other model parameters would change. But maybe those functions don't lend themselves to this context. Maybe the magnitude of change isn't correct. So in my mind, I'm not a soil scientist, but my impression is folks like Whittle are starting to make these measurements, and those will be good, but we just need enough of that to be able to to kind of gauge whether or not the model is predicting things correctly. So validation. So,
and I'll add just a little bit to that specific example Gray brought up, just to maybe illustrate this a little bit better. If we think about the pedotransfer functions that are used to translate soil organic matter into water holding capacity, those are mostly developed using some large pre-existing databases like the Soil Characterization Lab database. And those are basically, you look across all the soil cores that have been taken as part of the soil survey, and you just develop a regression relationship. The problem with that is you're not honing in on a specific soil and looking at, this specific soil changed itself from, say, 1% organic matter to 2% organic matter. What is then the change in water holding capacity for that specific soil? So, it's just one of the weaknesses of these pedotransfer functions, which is sort of what Gray ended up using, just because that's the best option we have right now. But I feel like we don't really know if those pedotransfer functions are gonna hold for a given soil, a given field. And so that's where the need for additional research and some long-term studies is really needed.
Kevin Ferminek, I would really be interested in hearing your observations, since in your data, you were seeing different correlations depending if you were looking at the manured versus the no manured field. So what individual parameters would you pick out as important ones to be measuring?
Well, I guess the thing that we've been learning is there's a lot of complexity out here. And as I hear Will speaking, even within a field, right, it's how do we represent these point measurements? There's just large variability even within a field, particularly our glaciated landscapes, and then overlay these pedotransfer functions on those different soils within that same field may not hold. But I think in our case, I think as it was mentioned, so there, even though in our case, we might have fields that have the best aggregate stability because they're in dairy agriculture, the aggregate stability is high, partly because of the manure, but then the phosphorus content is also extremely high because of the manure. And in effect, then we lose more phosphorus under this situation with high aggregate stability than one with lower aggregate stability, just because of that nutrient content. So that's really, really, really a critical thing here. And I think even from the modeling standpoint, the model is probably most sensitive to the nutrient content in the soil if we're looking at phosphorus. And so these other factors just the signal isn't big enough. And then I guess one other thing is that we have to remember that sometimes the critical management action or acute management action might actually, the soil doesn't participate very much. Again, at the edge of field data, at least, everything's event driven, acutely event driven, and a single event can drive the entire annual load, or 2 events, 3 events. And therefore, what the soil may not have even participated very much in those events as far as the amount of loss at times. So I guess I'm not answering your question, Ann, but my hope as I'm trained with Francisco under the same shop that he went through, the soil physical properties I see as some of the main ones that we can promise, because we know that extra nutrients are going to lead to extra losses. But beyond that, how do we improve the overall long-term functioning of the soil? And I think the soil physical properties is where we've got to head. And of course, they're also connected to the microbial properties.
There is a question in Q&A related to this question of event size versus management. I don't know if anybody else like Leif or perhaps Jess would like to weigh in on that question, but yeah, can management overwhelm the effect of climate, or is climate going to dominate in these certain situations?
Yeah, I think I was kind of surprised when we started looking at the data that we had, and temperature and precipitation type events kind of overwhelmed the significant factors. And so I think you have to take everything into account. And if we don't get a handle on the climate, we're probably going to be, it's going to be an uphill battle to protect a lot of these watersheds. So it's not a happy scene. not the findings I was hoping for, but that's kind of what we're seeing is there are definitely factors that contribute to pollution, but once you add the temperature, the blooms are going to happen. You need the temperature and the nutrients, and if those properties are there, you're going to have the impacts. So.
This is Mike. One of the things that we're really trying to get at with ecological sites and tying it back to management is what for a given ecological site, which is in a common climate, common soils, common conditions within a given land use, what is the optimal or highest bar you can achieve within that land use. Also, for both reference conditions, if it was in native vegetation, for example, what kind of infiltration rates, what kind of hydraulic conductivity, what kind of organic matter content would you have, or potentially could you achieve, and then tie that back to those responses. What we realize as we apply suites of conservation practices is that the impacts on erosion and runoff, and then as you start to aggregate more farms in the watershed, the impacts on the watershed don't happen immediately. So how being able to catalog those for planners on kind of those impacts you would expect to see, some of the things that you'd expect to see in the watershed are going to really tie back more to the monitoring and the looking at it, modeling from a watershed concept, because not all farmers are going to apply practices in the entire watershed. So some farms are going to be more critical to water quality than others just because of their proximity to the water body, for example. So anyway, that's really what we're trying to get at, is trying to learn off of what others have done and apply that for conservation planners to make some wise recommendations to farmers. Thanks.
I'd like to jump in here and just say that I would like Mike to hurry up and get that done, because that is so important to laypersons like ourselves, which we have lots of agronomists and current farmers at AFT, but by and large, a good number of RCPP, MRBI, NWQI, and other in the emerging corporate sustainability supply chain projects, right, may involve folks who don't have hundreds of thousands of dollars for in-stream edge of field monitoring or to hire a SWAT modeler, and need tools and tips to immediately geographically target the right farms and the right locations, and know if they do get XYZ practice adoption from those right farms and the right acres, that they can expect A, B, and C water quality results in X, Y, and Z number of years, right? And if ceteris paribus weather cooperates and isn't too erratic. But I think all of those helpful techniques, and maybe you're translating what a lot of you have already talked about, you make the information useful to not only the planners, but also to the farmers. So the farmers who are looking at soil type, and so they can know that if they commit to financially and technically investing in soil health practices and don't throw in the towel when things go wrong, because they always go wrong during adoption and implementation, that they stick to it 3 to 5 years at least, that they think that they can, expect to see the economic gains, the soil health indicator changes, and the water quality gains with sufficient numbers of fellow farmers all moving the football down the football field together. And it would just be neat to have kind of like, I don't know if recipes are the right words, or just some kind of like, well, if you're in this kind of soil type, this kind of agro-eco region, this kind of tile dominated landscape versus not tile dominated landscape, this kind of phosphorus heavy watershed versus not phosphorus heavy watershed, all these like little cheat sheets, if you were, for a majority of the water quality impaired priority landscape project areas, that would be going a very long way, making a lot of progress.
Yeah, I think, Michelle, that you hit on something that I wasn't sure where to kind of fit in this conversation, but I mean, first to answer Anna's question, I think there's this intersection between management and climate, because what I'm curious about in some of LEAF's data is that, like, as the northern part of Minnesota warms up, we're seeing these water quality impacts, and part of that is because it's now warm enough for long enough of time of the year that we're starting to farm places that were never farmed before, or manage places. Decomposition is changing in a lot of peatlands, and that's altering water quality. And so there are all of these kind of intersecting, cascading effects. But when we're trying to tease out the management soil quality properties, there's this human element of that, where we have, in the study that I was doing, we observed that a lot of farmers were trying these practices in kind of their worst land. and maybe it's it's the nature, it's an implicit complication of on-farm work, because we're, and tackling that variability was exactly what we wanted to do. But it was also an incentive program that it only, incentivized you at a pretty low stakes, just a bit of your land. And so a lot of farmers, when they're trying things, inadvertently will try it on their worst piece of land already, because it's the most expendable piece of land. Like, why would I invest my highest productivity land in something that's risky and new? And so when we're then looking at the outcomes, how are we taking into consideration those individual choices by farmers, and like what that means for what we're trying to understand in these landscapes? Like, I think that's kind of a piece of the puzzle that came to my mind as well, is what we're really assessing in management, and how are we taking kind of the farm's perspectives and risk adversity into these equations also.
That's a great observation, Jess. And I'm gonna pivot a little bit from this discussion of which parameters and what do we measure and how do we connect them over to Lisa Duranchik's question about statistics. Okay, we need to do more research to get at which all of these parameters and how to connect them. But given that, What are the appropriate statistical approaches? How can we relate the point scale soil data to the integrated water quality data? And Lisa specifically is addressing this to Kevin. Talk about how that was approached in your GLRI study, but I want to open it up to everyone as well after that. Go ahead, Kevin.
Okay. Thanks, Lisa, for the question. Of course, Lisa's familiar with our projects and she's our technical point of contact for our project. But our current approach, and I should say Luke Loken, who's also in the audience here today, is from the USGS, is one of our key people working on this. So far we've taken a pretty simple approach. We're taking mean or median field scale values and trying to link those to seasonal, for instance, non-frozen year losses across 14 sites over multiple years. Now that's a pretty simple approach, but we are thinking more about whether we should be looking at the soil health points closer to the outlets of the fields and weighting those more heavily than the soil health farther away from the outlets of the fields, because they may drive the water quality, right? So that's a whole nother layer of looking at the spatial statistics on that. And maybe a model could help us weigh those, which points should be weighted heavier if they're on the shortest flow path, for instance, to the outlet. Clearly, we need to look at the multi-parameter approach here, and we have a lot of parameters in our bucket right now. And we're working through that idea of which ones are the most influential through principal components analysis and some other multivariate approaches. But we're looking for, I'm interested to hear Will and others on how we're going to approach this. Will's got a lot of sites. We have 14 sites. But clearly one of the benefits I think of this group is, can we even link more of this data together to understand what are the better other approaches that we can use to link the data.
Yeah, we gave it a go with this. I mean, we have a lot of farms too, and we gave it a go with this effect size approach to look at the magnitude of change with practices. And I think maybe some of our next steps are to figure out how to take those effect sizes and weave them into something like a structural equation model or other multivariate methods to try to think about some of the different covariates that we have. But yeah, I'm noodling through all of this too, like so many parameters on all of these farms and how to start making sense of them.
And you've got the advantage of having the paired sites everywhere, which can show the effects of, isolate some of the effects. So,
yeah. Yep. And we tried to do that as purposefully as possible. And we also at least tried to control for the soil type. I don't necessarily know that we did that completely perfectly. And like I mentioned, as we went through this, we were like, oh, it's the same soil type, but this was definitely like this land they put this in was in a lot worse shape, even though it's the same soil type. So, but yeah, we tried to control at least for soil type in each of those site pairs also. But
yeah, I guess I'll chime in. In our project, I guess, we've used mostly a similar approach to what Kevin described up to this point, at least, where we take a number of samples from our fields and either take the median or just the straight average of the values we get from those samples and use that to hopefully represent the field. Whether or not that's a legitimate approach, I think partly it's a question of just what's practical, what is feasible to actually do. Of course, from a statistics standpoint, it's always better to have more observations, as long as they're, good observations and not, poorly analyzed or something. But assuming they're good observations, it's always better to have more. But the flip side of that is, we have limited resources, logistical issues. It rains, then you can't sample for a week. So it's a matter of trying to hit this sweet spot between getting a lot of observations and also actually getting the observations and getting them analyzed. Yes, so that's sort of, I guess, just laying it out there. It's sort of the reality of the situation. we're actually just this fall, we're doing another big sampling campaign at our edge of field sites, and we've managed to increase our sampling intensity a little bit, our soil sampling intensity. But again, when you have so many sites and a limited number of people, you just try to do the best you can. We do try to take some of the approach that Jessica was describing in terms of looking at the soil maps of the fields beforehand and trying to strategize about where we want to take our samples. We try to capture the variability, or what we might expect the variability of the field to be, just based on those pre-existing Nrcs soil maps. I do think it would be really great if someone would put in some concerted effort towards trying to answer this question. There has been some work done in terms of soil tests, phosphorus, and soil test potassium, in terms of trying to understand the variability at a field scale, how many samples you need to take to actually get a good representation of the field average. But I don't know anyone who's tried to do that for more soil health type measurements. So if someone wanted to take that on, that would be amazing, and go and sample a field super intensely, and then sort of back out how many samples they actually needed to get close to the true average. I think that would be excellent. And then the other, even, on top of that, like Kevin was mentioning, you have this potential complication of the variable source area hydrology. That's sort of the term we use in USDA, at least. So there's a group in Pennsylvania that's done a lot of work on some of those fields that have more topography than we tend to have, but they've shown very, very convincingly that, the whole field doesn't contribute to runoff. It's really just a small area of the field that contributes to like 90% of the runoff events come from just this small, 10% of the field area. So when you have that complication on top of it, it's just another challenge. I know they're working on some modeling efforts to hopefully make available some of those potential answers to what part of the field you might want to focus on. But I haven't heard recently where they stand with that, but hopefully those tools will be made available at some point, so people can get a better handle on variable source areas. But yeah, it's a challenge, something we're continuing to think about, but no great answers right now.
Would we get further along by developing models such as SWOT, or focusing on more of these other heavy sampling approaches?
So I think there are a number of studies that have done similar things for soil carbon. And I know on our smaller watersheds that are about 1.4 hectares, we have grid sampled sufficiently to create zones that are uniform that we can look at the overlying management, but there's no specific methodology or approach, because you have to assess some of the factors that are specific to the area that you're looking at. But there are approaches that are published that people can take, and that could then, go back to the original question about whether management versus climate is important. I think you have to look at scenarios and you have to bound them. And there's a minimum and a max for extremes, and then there's the average. And so if you have average climate, then the soil factors make more of a difference. If you're looking at extremes, then you ignore it in the model. And I think some of that's already built into some of the existing models too.
Yeah, I've been looking at this spatial variability in a couple of different ways also. So in the study that I gave this talk on, we had these site pairs, and at each site pair we had, we did a pooled sample. So we, as is usually good practice for taking soil samples, we took several samples and pooled them together. But then I have one project in kind of a perennial sustainable ag system where we actually are working with a USDA scientist here that has eddy flux towers. And so we have two big fields with eddy flux towers in the middle. And we have this full kind of nested spatial design of how we are soil sampling that field across it. And we're hoping, we just got this started this year and we don't have a lot of, we felt pretty good that we did anything given COVID, but we kind of got that rolling this year, and we're planning to do some different kind of modeling approaches in the future to see how that spatial variability plays into the kind of larger eddy flux measurements that we see across those fields. And the other kind of interesting approach we're taking, that I would pass this off to one of our other organizers, is a project that that I'm participating in with Anna Cates and Anne and Hava, our PhD student. Maybe it's worth kind of describing our spatial sampling approach at the SIG project, because that kind of plays into this as well. It'll be really interesting to see what our spatial variance comes out as.
Sure. So like some of the studies and the panelists presented in their videos, we're really trying to get at some pieces of landscape variability by sampling multiple landscape positions within a given field. So we have, for the most part, paired fields of one side or one field that would be addressing some combination of soil health management practices, and then one field that we call a more conventional or business as usual practice. And then on every field, we try to sample what we consider more of an upper, so like a shoulder or a back slope position. And then we're also sampling a lower foot slope type position on the landscape, just to try to get a handle on some of the topography. And depending on where you go in Minnesota, you have more or less topography. So that really gets at just the importance of recognizing the slope and what some of those factors might be. And we are measuring a big suite of soil health indicators on those different landscape positions. So we're hoping to just shed some light on that landscape scale variability. And it's a pretty simple design. We're just using 2 landscape positions. Really, you could split that out. I think one of the presentations that I watched just recently from Ontario, they split out many different landscape positions, but at least it starts to give us some idea. What's the range? How can we start ballparking these expected values in these different scenarios with soil and management?
Mm-hmm. I can add a little more to that conversation. We looked at the very first part of the presentation. There were 5 landscape positions that we wanted to have a look at. And there was quite a bit of variation across the 5 or 6 different metrics that we used. And when we started the exercise, we wanted to expand it. So we would look at means, and we would look at kind of a variability around the mean. So if there was a tight distribution around the mean, then it would mean that management doesn't make much of a difference. But if we have a broad distribution around that mean, then it would mean that management can alter it and make that distribution wider. And then we did that exercise and we said, well, the management was the same, but the landscape position was different, and it had a huge effect as well. So I'm not sure what we learned other than just it was complicated, and things like this are help to really help us all to move this whole process along.
There's a couple other interesting questions in the Q&A, but I wonder if we should zoom out to a policy level at this point. Anne, what do you think?
Sure. Yeah, that sounds great. So given all of what you're hearing, how does this research relate to policy decisions? How does it relate to watershed management, as Michelle has been talking about?
I think we have to, obviously we have to take climate change into account, right? We have to take into account the fact that our normals of water loads on the soil and climate impacts on how we manage land are changing rapidly. And so I think we have to take into consideration the moving target within which we're trying to improve water quality.
Think about some of the policy that people are working on. On the one hand, BMPs, equip, those kinds of cost share programs, and how do you write those kinds of rules? and some of these other policies, what is the research that these folks need to make better decisions on writing these policies and rules and programs?
I think the policy, it's needs to focus on the management, right? I think it would be difficult to manage on specific salt properties, right? So the salt properties needs to inform maybe the type of management we need to do. And we know some of the management is useful, and I think the key maybe moving forward, I guess in the future, would be where in the landscape, right? Where in the watershed should we be targeting? And I think Michelle talked about this, because we know, there's certain parts on the watershed that might be contributing the bulk of the nutrient losses. So, but that's sort of difficult in that it also might get into privacy concerns and those type of things as well, right? And so it's difficult from that standpoint. So I think, scientists, we always want to have more information, but I think we have enough, and Michelle showed that, right? That we have enough, I think, to start moving forward. And then as we move forward, we make tweaks and improve those models and hopefully improve the decision aids too.
There's a real communication challenge here, balancing our uncertainty with our hope or expectation for directionality, I guess. That's something that always comes up for me in trying to interpret this kind of research to policy.
One of the, go ahead.
Oh, sorry, just one sentence to play off of that. And I also think that the more, or maybe this is a hopefulness also, that the more we see people trying things on the landscape, the more we'll learn. And so it seems like a general policy that can, reduce risk and encourage people to innovate in general, I think is gonna, teach us a lot. I think the more things people are trying on the landscape, the more we're gonna learn rapidly.
Yeah, I was just gonna say, one of the kind of interesting things that we saw in our trend analysis was that a lot of the lakes in the metropolitan area actually improved, and which is an indicator that actually the best management practices, there's been a lot of efforts at the different scales of stormwater ponds and rain gardens and street sweeping, all kinds of things seem to do have an effect if they're implemented at the right scale.
Like that Les Everett just brought up the time issue of there's this time lag, and how does that impact how we choose sampling and rulemaking and such. I want to, as well as BMPs and cost share programs, let me throw in the other example of where we use a lot of this information, and that is in the market or the private sector for certification, whether it's for regenerative ag or for carbon storage or whatever. But there's those people are also trying to track what are the soil parameters we can measure to certify that these people are getting the outcomes they're looking for.
From my standpoint, I think that these policies that obviously keep the land covered, so reducing the vulnerability, and clearly the models are sensitive to this, and we know that translates to improved water quality, whether it's roots in the ground, green plants, and the cover. And then from the soil health improvement standpoint, I think it's pretty clear, the literature says, right, if we put more roots in the ground more often and reduce how fast we're losing our organic matter, that things will improve. Now, that's not always translating, and so far we're not able to translate that to water quality improvements yet. But I do believe that'll be translating to some of that resilience components related to climate change and hydroclimate constraints. For instance, in Wisconsin here, we had the 2 wettest years on record in 2018 and 2019. Fields that were in no-till were able to be more resilient to workability and so on than other conventionally tilled fields. Now, again, it's going to take time before that resilience builds up through the physical parameters so that they can handle these sort of constrained years and bounce back sooner. But I think that's the direction we'll go. But unfortunately, selling this to people that it's an improved water quality that we can measure, I don't see that easily measured yet.
So we have got 5 minutes to go. And so I want to ask everyone for final comments by answering this question. What's the next research you'd really like to do?
I don't even know where to start. This wide-ranging conversation is like, which idea do I pick?
I guess for the daily erosion project, having that kind of data for different landscapes instead of just agriculture. I mean, one of the limitations was it was just for agricultural watersheds, and not every watershed is 100% agriculture, so you got a lot of other factors in there too. So maybe expanding it to other land cover types, and I think having the daily precipitation erosion data could be very powerful. One thing with lakes is there's a delay of when you're going to see the effects. You're not going to see them when you have a big storm. You're going to see it usually when the temperatures increase in the late summer. So that's a lag period that you have to consider. But definitely that would be an interesting study.
Ross, were you getting ready to respond there? You're muted.
I was still working on the policy thoughts. And then when you lob the next research into the pot, it really it had me thinking. I think there's a lot of work that still needs to be done. I think it's important from my perspective anyway, just to leverage what I've already done, the approaches that we've already taken. There's been a lot of good information and everybody seems to have a slightly different approaches. And I think it's great that everybody can just continue it on the process, and it's just very iterative, and the slowly we move it all along and we gradually link it, 10 years from now it'll look more cohesive than it does right now.
Okay, Anne-Marie, did you have some thoughts on this?
Yes. So what I hope to do is to do some in situ radiometry initially in smaller field plots, and then that'll enable me to measure about 10% of the samples that I would typically need to measure, and then eventually scale that up to do larger areas with remote sensing, with ground truthing of both the radiometry and measurements of soil health. Thanks.
Gray or Will, what's going to happen next in Ohio?
Well,
Go ahead, Gray.
Well, I'm looking forward to Will's data. So again, I want to switch out those pedotransfer equations in our methodology and reduce some uncertainty in our results. So I'm looking forward to data to validate our models.
Yeah, so we're moving full force ahead on trying to obtain more soil health measurements from our edge of field sites. At this point, we really only have that 2017 sampling available to us. So trying to build up our soil health database to see if we can see relationships with the water quality. And, a part of that hasn't come up yet, but something we're really interested in Ohio is how these soil health parameters might influence the partitioning of water movement from surface and tile drainage. In Ohio, we have basically our entire western Lake Erie watershed is tile drained. So it's of massive importance for our water quality issues. So just trying to understand what's going on with surface runoff versus tile drainage and how soil health might impact that.
That's great. Arun, did you have any closing comments?
Yeah, similar to Will's, we are also trying to see the same impact, and we are also trying to see how in the next project we are trying to see that how the termination of these we studied the cover crop where we link the rye biomass and water quality, and then in the next project we are trying to see how the different termination dates and how the different biomass gain are impacting those soil health and water quality properties.
Great. We've got, who's left? Mike, Michelle, and Francisco.
This is Mike. I'll just jump in here real quick. Just a couple of things that I would see. One is we mentioned WEP and WEPs and within those, if we can start to get research that would support as soil health indicators and soil health management, improve those soil properties from what we're using in Surgo, for example, what kind of impacts would that have on water partitioning and erosion? And also one of the things that I worked with was developing a soil health literature database that was tied to practices and mainly physical properties and changes in physical properties, but also chemical and biological properties. And one of the things that was very difficult to do was get repeatability from in the research. In different words, were they on the same soil type or landscape position, such as what ecological sites would be, to be able to say, okay, with these practices that are employed for this length of time, what kind of impact would they have? Also, trying to look at what the pre-existing conditions were for previous management. Too often, the studies would have short-term no-till or cover crops or whatever it would be. And so quite often you were comparing apples to oranges with literature. And so one of the things that, again, just to simplify it, would be helpful, soil health impacts that are tied to specific soil types or ecological sites, and what we could expect, also the potential for improvement. So those types of things would help us.
Great. Michelle?
I'll just say really quickly, if people want to make me smarter on this nationwide calibration data set, I welcome that. We need all the help we can get. So email me bullets, ask for a call, put me in touch with the right people to flesh it out. We want to make it smart, useful to all of you, useful to all of the tools.
Thank you, Michelle. And if you want to add a link so people can find that, put that.
It's not out yet. We're aiming for Wednesday, but it might be December 1.
Okay, well, contact Michelle. Francisco.
Yeah, I guess on my end, one of the things I'm really interested in is trying to figure out where is the goalpost, right? How much is enough for any given parameter of soil health? So I'm honing in more in aggregation, not just stability, but also the fractionation. Obviously, that links with infiltration and all other functions of the soil. So that's one thing that I'm planning to work on and trying to figure out, okay, where do we need to go? Where is the end, right? Or where's a range that should be suitable for a certain function in the environment, in the ecosystem. So
Great, thank you. And then let's see, Anna, do you have any last observations as you've been listening to this over the last hour and a half?
Well, it's been great listening. So thanks everybody for the engaged participation. I think this is just what Anne Marcella and I were hoping for in terms of getting a lot of expert voices working on this issue, kind of talking out loud for an hour and a half. So you've met and exceeded our expectations. To me, there's these two kind of parallel tracks going forward to continue these tracks of sort of direct policy tools. And we want them to be talking to the on the ground research. So I think that's kind of our goal, is to keep those tracks moving forward and in communication with each other at these different scales, different tools in terms of models versus in-field measurements.
Thank you, Anna, and thank you to all of the panelists. I really appreciate your time, and this has been some great discussion. We've made a recording of this. We'll figure out what we're going to do with that and let all the attendees know. And I would just say have a good afternoon, and thank you to everybody for your time and attention and some great questions.
And Marcel, thank you so much for all the work that you've done and that you're continuing to do with working with me on getting some publications through. You really deserve a big applause.
Thank you.
And I'm just going to put in really quick for any attendees that are waiting. We did have some really good questions that we did not have time to answer because they were specific to a given study. If we didn't get to you, we will try to follow up with the panelists and see if we can get those answered. So thank you for all of your questions from attendees.
Thanks, and thank you to you, Cower. Have a good day, everybody.
Bye. Thank you.
Thank you.
I think that went really well.
Yay.
Yeah, I'm gonna stop recording.